Beginning of our notes. Okay. So our last section is 2.7 nonlinear inequalities. Before we actually talk about nonlinear inequalities, I would like you to. Oh, I need to take a timeout real quick. Did I tell you when those assignments are due? I did not. Those half sheets are due tomorrow. That way I can grade them and give them back to you Thursday before the test. Okay? So those half sheets of paper, mark it on your gold sheet, mark it on the half sheet of paper. They're due tomorrow. I apologize for that. What?
That's the quiz corrections. That's the quiz corrections.
Well, they're not quiz corrections. It's a quiz follow-up assignment. So they're different problems, but if you got those correct, then your assignment shouldn't take you very long because you'll just do the same thing you did on the quiz. Do you see what I mean?
Yeah.
However, if you missed any of those questions on the quiz, you have the chance to redo a problem. It's a different problem, but still show me that you have mastery of that skill. Are we on the same page?
You got it right on the quiz. You like your minus points on the quiz for that.
The quiz is not going in the grade book, but that worksheet is. Okay. Okay, so this is what I want you to do. We are going to talk about nonlinear inequalities. And before I tell you the process, or even introduce you to the types of problems we're going to see, I want you to think about this. You and your pod need to graph this on your calculator, and I want you to figure out when f of x is greater than 0, and then answer these two questions. Okay, I want you to do a little exploration for me, if you will. Oh, pod 4. If you don't have a tight time, I'm giving you something quick. Then give you about 1 minute. Talk in your pod. It should not be quiet in here.
It's supposed to say 1 f of x is greater than 0, and it's we're looking at a graph.
Less than
How would you say that?
Yeah. From 0. No, from 0.
Greater than f of x, y is greater than 0.
Maybe.
That's when negative 3. X is less than negative 3.
But why negative 3?
Because that's when it crosses that.
That's when it crosses the x-axis.
How would you know?
When f of x is greater than
0. Where it crosses the x-axis is where it's gonna be greater than f of x is greater than 0. So it negative infinity to negative 3 is all above the x-axis, and then from 2 to infinity is above the x-axis. Here it kind of f of x is less. So you'd say negative infinity to negative 3, and then 2 to infinity.
All right. Do you agree that your graph looks like this? Okay. When is f of x greater than 0? 5, what can you tell me? When is this function greater than 0? What would we be looking for on the graph? The values above the x-axis, right? Okay, so how would we describe that in interval notation?
Think about, I don't know, the domain that's above.
Yeah, so what is the domain that's above the x-axis over here?
Negative infinity to negative 30.
Okay, and what about over here? Okay. What were the most important points you had to think about when deciphering where the function was positive versus negative?
The x-intercepts.
Okay, those x-intercepts were pretty important, weren't they? Okay, our x-intercepts separate our graph from where it's positive to where it is negative. Okay, since we were looking for where f was just greater than 0, we didn't have to include our intercepts in that interval notation. Okay, but from negative infinity up until negative 3, we're above the x-axis, and then from 2 to infinity, we're above the x-axis. Okay? You just solved a nonlinear inequality by looking at the graph and determining what pieces of the domain fit our inequality. Okay? So, when oh, no, that's not what I want. When I give you a nonlinear inequality, these are the steps that I want you to take. Now, you're not going to have a graphing calculator in your hand, so we're going to need to figure out a way for us to be able to solve them without using our graphing calculator. Okay? Now, luckily, we do know how to graph, but there is another way to do it without looking at the graph every time. Okay? But you did point out a couple of things that will be important when we solve these equations, or inequalities, excuse me. So, I asked you what points were critical in determining where our function was greater than 0. You told me x-intercepts. That's going to be true for each problem. We need to find the x-intercepts, or the zeros, so that we can determine what is separating the positive from the negative piece of our graph. Okay, and that happens at the zeros most of the time. Okay. Now, instead of actually having to graph the equation every time, I'm actually going to ask you to test intervals. Okay. And I'll show you what that means, but basically, we're going to put the zeros on a number line instead of like a coordinate plane, and we're just going to test values to figure out where our function is positive versus negative. Okay. We're going to do that by evaluating the function with an x value that's in between our zeros. Okay. In between our zeros, the graph is either all above or all below the x-axis. So we're just going to test a point to see if it's above or below. And then you're going to be able to express your answer in two different ways. I'm going to have you represent your answer as both a number line and then an interval notation. And I'll show you both what those look like. our little intro slide, our answer in interval notation was negative infinity to negative 3 and then 2 to infinity. If we were to represent this on a number line, okay, we're literally going to make it look like the interval notation. From negative 3 to infinity and from 2 to infinity. That would be the number line notation. Instead of open versus closed circles, we're still going to be consistent with our brackets and parentheses. Okay, so do we know how to find zeros? Yeah, we know how to find zeros. Don't forget that we do know how to factor, and factoring is way less time consuming than the rational zeros test. So please always look to factor before you do it. Okay? All right, so first example, please write this inequality down for me. Okay. I'm going to go ahead and make like a step 0 on this page, if you can squeeze it in. Since we have to find critical values that are the zeros, let's go ahead and change our inequality by comparing our inequality to 0. The inequality that you just wrote down has a cubic that's like, what is it, less than or equal to negative 4. Okay? We're going to eventually need to find zeros. Let's first rewrite our inequality so that there's 0 on one side and then go from there. Okay? So before we do anything else, what I mean by that, I want to rewrite this inequality to be x cubed minus 4x squared plus x is less than or equal to 0. Okay, so now what I want you to do as I try to get this back online, please rewrite that as the equation x cubed minus 4x squared minus, okay. Okay, so now to find zeros, we're gonna write it as an equation just to find the zeros, okay? Yes, I know it's an inequality, but for right now, we're going to find the zeros, okay? All right, first we need to ask ourselves, can we factor? Okay, what method should we use to factor this? Grouping. I like factoring by grouping. Okay, so GCF in the first two terms is x squared. GCF in the second two terms? Negative 1. Since we have an x minus 4 in common, we can factor that out, and left over is x squared minus 1. Okay? We all know that x squared minus 1 is the same thing as x minus 1 times x plus 1. So our critical values are at 4, 1, and negative 1. so excited I changed my screen to get my scroll bar, but it's not working for me. It's so frustrating. Okay, this is what we're going to do. On a number line, we are going to plot these zeros. Okay, so here is 1, -1, and 4. Okay. So what we're going to do, okay, in between the zeros, our function is above or below the x-axis. We just need to figure out which one. So we're going to test intervals by just picking a number in between the zeros. So my first zero is at -1. What is a number between -infinity and -1 that would be nice to plug in? Okay, so I'm going to plug in x is -2. Now, when we plug in x is -2, what do we get? We have -8 minus 16 plus 2 plus 4. Is that going to be a positive or a negative number? I don't care what it is. Is it positive or negative? Negative, which means at x equals -2, we are below the x-axis. Is that what we want? We want to be below the x-axis. So that works, which means the entire interval is going to be below the x-axis.
So do we just draw the squiggly line?
And so you can like shade. I don't shade very well with this marker. So you can either shade, or I'm just drawing a squiggly line just to save some time. Okay, but most of you might just like shade darker, right? Okay, between -1 and 1, what would be a nice zero to plug in? Excuse me, not a zero. What would be a nice value to plug in? When we plug in 0, that's nice, we get 4. Is 4 less than or equal to 0? No, which means the interval between -1 and 1, that's all above the x-axis. It's not going to work. It's not satisfying our inequality. Between 1 and 4, what would be a nice value to plug in? I would pick 2. The smaller the number, the better. When we plug in 2, we have 8 minus 16 minus 2 plus 4. Is that positive or negative?
Negative.
It would be negative. And a negative number is less than or equal to 0, which means that is satisfying our inequality. So between 1 and 4 will work. And just to be sure, let's check from 4 to infinity. I would plug in 5. That's the smallest number we can pick there. When we plug in 5, and it doesn't matter what the value is, we just need to figure out how it compares to 0, right? So 125 minus 100 minus 5 plus 4. Is that going to be positive or negative? It's going to be positive, which is not less than or equal to 0, so that is not going to work. Okay. Now, our inequality did have less than or equal to as a part of it. So when we come back to our number line, we need to include the zeros at the endpoints of our interval. Okay. here would be the two different ways to represent our answer, number line and interval notation. Let's talk about how this relates to the graph. Our zeros were -1, 1, and 4. Since the leading coefficient is positive, we know that the right will rise. Since it's an odd degree function, we know that the left will fall. And since all of the zeros occur once, we know that we are going to go straight through our zeros. Does that match up with the intervals that we have described? -infinity to -1 and 1 to 4. Those are values that are on or below the x-axis, which is what our inequality was asking for. All right. Our polynomial equation is the only thing we've been working with this chapter. Now, what else do we have? We also have some rational equations, okay? So I want you to go ahead and write this one down, and I want you to look at the graph. Okay, so go ahead and just write it down first. You are going to get some rational graphs, rational inequalities, okay? So what I would like you to think about is how would our critical points be any different, or are they any different, okay? Look at the graph and look at what separates pieces of the domain that satisfy that inequality versus pieces of the domain that would not satisfy that inequality. Take 30 seconds and talk to your neighbor about what would be critical. Are just the zeros critical, or is there anything else we need to consider? 1, 2, 3, go. All right, take it in, Lindsay. I saw you two talking to each other. What do you think?
We said that the vertical asymptote you have to look at too.
Okay, the vertical asymptote you have to look at too. Did anybody else have that same discussion? Okay. At the vertical asymptote, it's possible that the behaviors on either side of the asymptote are different. So do you notice how this asymptote is separating pieces that are below and above the x-axis? So not only are the zeros critical, but also the vertical asymptotes. So maybe we need to come back here to our list. Critical values, find zeros and vertical asymptotes if it's applicable. I abbreviate VA if you want to write the whole thing, that's fine. Okay. So if we were doing this one, okay, so if we were doing this one, we would make our number line, And we have a 0 at -5, and we have a vertical asymptote at x equals 2. Okay? So this inequality, we're wondering where this graph or this function is greater than 0. So if I look at -infinity to -5, is that piece of the graph greater than 0? Yes, it is. What about between -5 and 2? Is that greater than 0? No, it is below the x-axis, so it is not greater than 0. Okay. What about from 2 to infinity? Are we above 0 here? We're above the x-axis, so yes. Okay. And since we have just a straight up inequality, we would have those parentheses. Okay. We're still going to do the same thing where we're going to test values in between each of those critical points to determine if we are positive or negative. Okay. But let me ask you this. It didn't matter in this example, but if I changed our inequality to this, could we put a bracket on 2? Why not, Caleb? You're very emphatic about that.
It's vertical asymptote.
Okay, we will never be able to include a vertical asymptote, no matter what the inequality is, because there's nothing there. It's undefined. Okay, so we will need to be careful when we are answering our inequalities that do have that equal bar as a part of it. Okay, so one example, and then we'll be done for the day. Okay, the first step I gave you was to what? Or the 0 step, right? Does this compare to 0? It does not. Is that something we graph? Rational -3. Okay, no. I have not given you anything like that to graph. So, in order to be able to determine zeros and asymptotes, we need to get this to be one fraction. Okay, that's fine. If we need to combine these two, that means we need what? Common denominators, all right? So we can multiply this 3 over 1 by x minus 5 over x minus 5. So 3x minus 15 over x minus 5. Okay. Now please be careful. Our denominator stays as x minus 5, but we are subtracting this entire fraction. So 2x minus 3x would be negative x, but we do have negative 7 minus negative 15. So if you need to put that subtraction through, you can, or just remember that we're subtracting. But we end up getting negative x plus 8 all over x minus 5. Okay? It's going to be a little simpler to work with anyway. Now, when we're talking about critical values, we are talking about zeros and vertical asymptotes. So we'll start with the one that we've been doing most often. Our vertical asymptote for this equation, Keegan, where is it? Okay, So x equals 5 is our vertical asymptote. What about any zeros? What gives us our zeros? What do we look at to find zeros or x-intercepts? Okay.
Well, we said it equal to 0.
Okay, we set it equal to 0. And if we set it equal to 0 and multiply the denominator over, anything times 0 is 0, right? So when we set it equal to 0, we're really concerned about where the numerator is 0. What makes the numerator 0? 8. So 8 is our 0. What's nice about this, you're basically looking, where is the numerator 0? Because that gives you your zeros. Where is the denominator 0? That gives you your vertical asymptotes. Okay. All right, so 5 and 8. Okay, so let's just test some values. What is a nice value to test between negative infinity and 5? I would always try to plug in 0 if you can. Okay, so when we plug in 0, we are left with 8 over negative 5. Is that less than or equal to 0? Yep. Okay, between 5 and 8, what do you want to pick? 6 sounds great. If we plug in 6, we get a positive 2 over a positive 1. Is that less than 0? Nope. Okay. Above 8, go as small as you can. I would pick 9 or 10 if you want, but don't get too out of control. Okay. If we plug in 9, we get negative 1 over 4. Is that less than or equal to 0? Okay, so now let's fix our number line. We know that from negative infinity to 5, it satisfies our inequality. Do we get to include 5?
Yeah.
Let's think about what is 5.
Excellent.
5 is our vertical asymptote, which means we cannot include it. Okay, but since we do have that equality with 0, we do need to include 8. Okay, so interval notation, negative infinity to 5, and including 8 to infinity. Okay. Always think about that vertical asymptote because we cannot include it. Okay, let's check. You have book homework. Okay, this is going to be important to practice. We don't have a quiz before the test. Okay, your homework is your informal assessment. Your homework is your informal assessment before the test. Okay, you need to do your homework. We'll talk about it tomorrow. Tomorrow we are also going to introduce the project. Okay, if you are not here, it's really important that you get that information. There is a lot of things that are very specific about it. So if you end up missing tomorrow, you need to carve out a chunk of like 5 minutes to talk to me about the project. Tomorrow is also when your quiz follow-up assignment is due. Just to be clear, the quiz is not in the grade book. I did write down your scores, okay? But that half sheet of paper with 2 problems, that is going in the grade book, okay?